So our first presenter this evening is Jordan Matchlinks. Jordan is a junior in civil engineering at OSU. When he graduates in 2013, he'll be the first civil engineer in his family. His brother graduated in 2010, but in mechanical engineering. So I don't know if there's competition there or who's better or what's the better engineering, but he grew up in West Lynn near Portland and is a first-generation American. His family came here from Belgium. He was the president of the Engineers Without Borders chapter last year. This year he doesn't have a role but he in the organization other than doing presentations like this, and he is headed to South Africa next term. Man can't get enough foreign travel apparently, likes to go exciting places, so welcome Jordan Matchlinks.
Good evening. First of all, thank you everyone for attending. It really means a lot when I come to presentations and there's so much interest. It's fabulous to see. Thank you also to Nick and the organization here at the Science Pub and the New World Deli, or rather, the Old World Deli. Anyway, apparently I can't count because those mistakes were likely mine. So I'm still a civil engineering student, not an engineer yet, so don't worry. So, like Nick said, my name is Jordan. I'm a junior. Ooh, that sounds weird. I'm a junior now. I'm a junior in civil engineering here at OSU. Planning to graduate 2013, but that's kind of up in the air. What with study abroad plans and who knows what else. A lot of things seem to capture my interest, so I'll probably be in school for quite a while. So tonight I'm here to talk about Engineers Without Borders. I was the president last year for the last school year. So essentially, well, first off, how many of you guys have heard of Engineers Without Borders? Ooh, excellent. How about before you read the agenda for tonight? Oh, okay, good. How many of you guys knew there was a chapter here on campus? Perfect, about the same. So you guys probably know a little bit about the basics. We're a student organization at Oregon State. So we're student run, student organized, the fundraising is all done by students. We do have faculty advisors and some professional mentors and some other qualified people who come check our work. And then I'll get into a little bit about the structure of Engineers Without Borders USA, the national organization, of which you saw there about 250 chapters. I think this year it may have diminished a little bit down to 230 or so, just based on some fantastic budget cuts. So the vision of Engineers Without Borders as a whole, as you can see, is a world in which every community has the capacity to meet their basic human needs. So that means things like water, basic sanitation, basic education, a lot of things that here in Corvallis and everywhere around what we call the developed world, we sometimes take for granted. So trying to redistribute a little bit of the wealth into these communities that have such dire needs, as you'll see in just a few moments. So our projects have mainly been focused on water accessibility, potability, sanitation, and generally transporting water to a more central location within communities. And we try to do that and really instill a sense of community ownership in the project, because the more I've gotten into this kind of development work or whatever you may call it, the more I realize that it's a very complicated science. I used to think, when I first started thinking about joining, that you go somewhere, you see an issue, you fix it the way you know how to fix it, and that's that, you know, rub your hands and off you go, take a little bit of the culture in, and there you go. However, it's a lot more complicated. You'll see in the next slide or two that there's a lot of sustainability associated with this concept. It's not just build what you know how to build, but also tailor it to the community, and really make sure you know what the community wants from the organization that you're working for. Because a lot of organizations that go and build wells in Africa, for example, or go build water piping systems anywhere else, say Central America, for example, we've had a project there. A lot of times they come and they build these systems, and they build it the way they think is right, and then they kind of up and leave and say, here is this fantastic gift, a source of clean water. Here's a well for you. But if it's not really what the community wanted, then they might tie a string to it and hang their clothes to dry on it instead, because it's just not what they're used to, and it's really not what they were expecting and not what they need, essentially. So it's not only a waste of their time and energy, but especially your own organization. So it takes a lot of research to be resourceful and not waste the resources you have, and really know how to apply what you have, because a lot of times in these not-for-profit sectors, there's a lot of tight budgeting to be done. And appropriate technology is another important one. That's more on the side of the recipients, the beneficiaries of these projects. So that's more something like installing a hand pump, for example, instead of a solar pump in a very rural community, say in Africa. Because most people in Africa, or most of the communities that will solicit aid of this type, they know how to work with things mechanically. They're extremely resourceful communities. They know how things work. However, they may not have access to electrical components. They may not know how to operate or especially fix something like a solar-powered pump. So we need to make sure that we know what sort of technology the community is used to working with. And as far as the people, kind of on our end of we try to develop students and engineers who are more globally minded. So a lot of students, engineers and non-engineers alike at Oregon State or any other university, they'll go through university, and I speak to a lot of people who just say they kind of want to stay around here, stay around home, which is fantastic, and there's nothing wrong with that. But having certain people a little bit distributed throughout all of the colleges who have access and use their international resources a little bit better can make a profound impact in a much larger area. So I talked a little bit about sustainability. More specifically, economic, social, and environmental sustainability are some of the biggest issues here that we're working with. So economic, I mentioned a little bit about it. We need to make sure that our systems are affordable for the community, because we work with the communities, and so we have a partnership. It's not just presenting this gift in the form of materials. So we do solicit help. We have a partnership. We have agreements in the forms of memorandums of understandings or contracts where applicable. It needs to be maintainable and reproducible, like I mentioned. Maintainable is a big issue because as a group that's based here in Corvallis, obviously if something goes wrong over in El Salvador or in Kenya, as you'll see in a moment, we can't just hop on a plane and go over and tighten some bolts and fix some things, rewire a circuit or something, and come back, because obviously that's not financially sustainable or even feasible for our organization. Social impacts are something that I've learned a great deal about that I really didn't expect to learn about in this kind of work. Not only does it need to be socially acceptable and socially sustainable, as I mentioned earlier, but you need to make sure that when installing a system, for example, the water systems that I'll talk about in El Salvador that we built, you need to really discuss with the community and see where they want the water storage tank, for example, the end of the line. Where is everybody going to come to get the water from these communal sources? Because given the engineering mindset, there's an obvious place. There's a higher ground up here. You put a pump here. You can run it down very efficiently. You can get the maximum flow rate and all the things that go through engineers' heads on a daily basis. However, there's a lot of social implications that has. So where you place the tank may or may not bring a community together. And there are instances, thankfully not in our organization for the most part, but I have heard of a lot of other instances where sometimes these systems tear a community apart, and there is jealousy and there is sabotage of certain systems because some people have to walk further, some have to walk further, some have to walk not quite as far. And so there are all these social dynamics that need to be analyzed. And so, of course, as an outside organization, there's no way we can do that. So we really need to communicate with the community and see where they want the system installed. And even if it's not the best technically, you just have to go with it to have the most profound effect possible. As far as environmental sustainability, a lot of what we do, well, actually, for the most part, what we've been doing is water projects. So in El Salvador, for example, we tapped into spring sources and surface streams. And so there's a certain amount of water that runs during the dry season. There's way too much water that runs during the wet season, and it's all dirty. So you have to find the right balance, the right structure. Here you can see a little bit of a pool that either we built or the community built after our departure. So you can gather a lot of water, but you need to realize that there's always somebody downstream, for one. There's always somebody or something downstream that needs water. So you need to make sure that when you initially survey the area, like you'll see we're doing in Kenya currently, you need to make sure you calculate at least roughly the flow rates of water that go through the wet season, the dry season, and everything in between, because you need to make sure that you're not taking an amount of water out of the stream or the spring source that is not sustainable. So again, humans and ecosystem alike, there's always somebody or something downstream, and as we all know, everybody needs waters. So Engineers Without Borders, OSU, just finished because we're still in the process of writing reports, and we're in what we're calling an extended monitoring phase of the El Salvador project. This project started in about 2005. We partnered with two communities, Las Mercedes and El Naranjito, in the mountains of El Salvador, which is about 3,000 feet in elevation, beautiful jungle area. You can see the beach and the Guatemalan border, which is a river, about 30 miles from the beach. And so up here is a picture. That's the kind of terrain we were looking at. And we are in our initial assessments, we counted about 750 people throughout all of these communities, just because the terrain is so enormous and so varied. Sometimes you'd have a couple houses up here, a couple over on this ridge, and then you see the next community is over here. And so when you say you're going to your neighbor's house or somebody, you're not going down the street. You're going down a valley, up a valley, through some hills, crossing creeks, and you're probably not going to get there with clean shoes. And that's a lot of the issues with collecting water, because most of the time, any springs will funnel down into the bottom of these ravines. And for agricultural and other social reasons, historically, most of the communities are built on top of these ridges. So as you can imagine, living at the top, water's at the bottom. What does that mean? You have to go down and up every day. So what we tried to address was the water potability and accessibility. Not only do they have to walk, or did they have to walk so far, but a lot of times, and especially during the wet season, there's so much mud and debris flowing in that the turbidity levels of the water were enormous, and you'd essentially just get brown water. And without filtration systems, a lot of times they either did nothing, maybe used a chlorine tablet if they had another one left, or just used T-shirt. You just pour the water through the T-shirt, and it still comes out gray, but what are you going to do? Sometimes that's all you have. So initial site assessment was 2006. That was our first trip. Since then, we've had 10 trips and 26 students travel to this area, as you saw earlier in the quiz. And so we constructed 2 gravity-fed water systems, which consist of an infiltration gallery, as we call it, which is essentially a fancy way of saying you dam up a spring source or a creek, you put the right layers of gravel and sand, fine and coarse, as technically specified in all of the reports and the research that our members have done. And then you lay some perforated PVC pipe, for example, under the bottom, and in theory, all the particulate matter will stay on top, the water percolates down into the pipes, and down you go. And depending on the elevation difference and the distances you have I think we built 2 systems that were up to 1.3 kilometers in length. And then after we built those, we returned, and the community members had built 2 systems on their own, based loosely off of our systems, which was terrific to see that community ownership. And their longest system was 2.2 kilometers, so blew us out of the water. So hats off to them. The other project that we started was in Kenya. That started in 2009. That was our first assessment trip. And June 2011 was our most recent assessment trip. So what we have now is a basic layout of the land, of the community we're working with. We have the basic community ties that we need to work with. We know a little bit who's who, what we can do, where the water sources are, and a little bit more about the systems that they envision. The size of the community, about 5,000 people, but it's such a, again, varied landscape. Here you can see it's quite flat. In other regions there's a bit of elevation difference, but the residences are so spread out that it's really difficult to take a very accurate count, especially because a lot of times the borders between the towns and all the communities are really just not well defined. So while I'm on the topic of water filtration in El Salvador, in 2007 we distributed about 50 of these, what we call Potters for Peace filters. Essentially, it's a 5-gallon bucket with a lid. It's got a little tap here and a ceramic pot. Simple, right? Well, turns out that's essentially all you need to filter out 99% of all the bugs in there. It'll get almost all the particulate matter. It's infused with colloidal silver, which I don't know much about chemistry, but it does take care of most of the living bugs and the parasites, all sorts of bacteria. So I traveled to El Salvador in 2000, well, where am I looking at? March 2011, so this past March. It was our final assessment trip, and I got to see all of the filters that we had distributed and some that we left with them to kind of redistribute and sell as they see fit. And I did drink out of one of these. I can tell you it worked compared to the unfiltered water. Don't ask me how I know. Yeah. So it does get clogged. As you can see, it's solid, so it doesn't filter very quickly. A lot of the issues that we discovered with these were, they're very fragile. They're very light. So in the communities that we were staying with and that we were partnering with, there are dogs and chickens and all sorts of things inside the house, outside the house, in your bed, under the table while you're eating breakfast. Peace Corps volunteer that we were staying with did step on a little chick. So it's that kind of environment. So obviously things are moving, all sorts of animals. So these things do get knocked off tables, especially considering the furniture that they have. So it's not a long-term solution. However, it was an excellent catalyst to kind of present the contrast between filtered and non-filtered water, because before we distributed a handful of these, most people were using the t-shirt method or nothing or chlorine, so they were still getting brown water, just really unsanitary for many reasons. So this kind of presented the contrast and really, I think, gave a large sense of motivation to install these other systems. So student benefits for Engineers Without Borders: hands-on international experience. Not very many other student groups that don't require an undergraduate degree or membership in something else allow you to do this kind of international work. And even if you don't actually travel to the project country, there's so much work to be done on campus. A lot of communicating on telephone conferences or conference calls with these community members, with the community leaders. There's all sorts of research to be done. There's tons of contacts to be made, including working with the on-site organization, as mentioned in the quiz earlier. In El Salvador, we partnered with a Peace Corps volunteer, and it was actually 3 consecutive Peace Corps volunteers over our 5 or 6 year partnership. So we had excellent timing because the last week that the Peace Corps volunteer was there was the week that we were traveling into the community. So he knew exactly who was who. He knew exactly how we should get our general quality of life surveys done. So without that sort of partnership on site, you're kind of going blind into a community that you don't necessarily know. You have a very difficult time sourcing parts, materials, labor, pricing for all of these systems, just because as student travelers, we can travel only December, March, and through the summer. And in El Salvador, that wasn't too much of an issue just because it's relatively inexpensive. However, now that that project's more or less wrapped up and we're moving on to Kenya, it looks like we're going to need to invest in longer travel periods just because the price to get there is so large. So right now we're looking at one trip per year to Kenya, usually about 2 to 3 weeks, depending on the purpose of the trip, if it's implementation or more monitoring or surveying. We also both organize and attend a lot of workshops and conferences. There's the Engineers Without Borders USA organizes a handful of workshops each year. They have an international conference where you can meet people from all over the world. I mentioned earlier there are about 15 countries in the world that have Engineers Without Borders organizations. And there are also regional workshops, one of which is coming up here in the next couple weeks. We're lucky enough that it's in Portland as opposed to San Francisco last year, so we're trying to get as many people to attend as possible. And I will note it is open to the general public. You don't necessarily have to be affiliated with Engineers Without Borders. So that means you guys look into it on Engineers Without Borders USA website if you're interested. Networking is a big thing also, as equally on campus, off campus, and internationally. As I said earlier, you can work with Peace Corps volunteers, a lot of different organizations, notably the Potters for Peace organization that we communicated with in El Salvador back in 2007. There's a lot of resources on campus I've been learning through this organization. There are a lot of professors, a lot of studies and research and things that are all extremely applicable. So it's a way to bring all of that together to the students and the Engineers Without Borders projects as a whole. Public speaking is a big one. When I first joined Engineers Without Borders 2 years ago, I did not expect to see myself right here or at all the other presentations that I've found myself doing. It's a contagious organization, and so you just have to spread the word any way you can. Another student benefit is enhancing your employability. Obviously, it'll look good on a resume if you're on the board, if you're just a participant, if you've traveled internationally. It looks pretty good. And as well, learning to work in teams, it's not, yes, as an engineering student, you do have to work in groups. You get assigned to lab groups and surveying groups and all sorts of project groups. But it's definitely not the same environment. There's nothing to turn in for a grade. Everything that you're turning in is really affecting somebody somewhere else. And that kind of motivates us to do our very best work. Not that we don't do our best work for grades, I assure you. But it really brings another sense of motivation, another sense of responsibility even, to be working on a project that has such a large effect, and I was reluctant to use the word profound effect before I traveled to El Salvador, but seeing the emotions of the people, the faces on all the community members when we left, tears were in everybody's eyes, including myself. So it's not something that can be taken lightly after you see that kind of environment and you really experience the work that you're doing, or at least being a part of. So again, here's some of the workshops that we participated in. Here, this is on the OSU campus over in Merrifield Hall. We were building a slow sand filter, or a model, because it's one of the systems that we're considering implementing in Kenya once we have water flowing into the community. So instead of a short-term system like this, a slow sand filter, is actually very common. However, they're mainly used on a municipal level. So football field size container filled with coarse gravel, coarse sand, fine sand. And again, it's the same sort of system as that infiltration gallery that I was talking about earlier. So all the particulate matter kind of stays on top, the water percolates down, and after a couple weeks or so, on top of that fine sand layer, there's a biofilm that starts to grow, and it starts to consume all the bacteria and parasites. And it's much more efficient than a percolating ceramic filter like this Potters for Peace filter. It's a lot more long-term. Maintenance is really just open the lid, you kind of shake it around, shake the water to bring up all the particulate matter that got settled into the top layer of sand, scoop out most of the water, but making sure that the top level of sand is still wet so that biofilm won't dry out. And that's about it. You fill it back up with water and you're good to go for another couple weeks, couple months. And as you can see, this thing is something about the size of a 55-gallon drum. So it can be made even smaller. Usually they're about a meter high for personal use. And I also drank some water out of that one in the community leader's house in El Salvador. And that one, like I said, almost no clogging, almost no maintenance. It's so much simpler. And so it's really one of the systems that we're looking to implement in the Kenya project in the future, just because of its general sustainability and ease of use and maintenance. And here's some more. You can kind of see the size of the group that we work with on campus especially. It's a really tight-knit group. You really get to know the people you work with and much more than a classroom environment. So with that, I believe I'll hand it back over to Nick, who will introduce the next speaker. So thank you guys very much for your attention.